Welcome to a video that will show you how to use a matrix equation to solve a system of equations. So first we can write a system of equations as a matrix equation, and this is how we would do it. First we'd set up a coefficient matrix for the variable terms. So the first row of matrix A would be 3, negative 1, and the second row would be 2 and positive 1. Next we'll let X represent the variable matrix. This system is in terms of X and Y. And then lastly, we have the constant matrix, which comes from the constants of each of the two equations. So the matrix equation would be A times X equals B. So if we use what we know about matrices to solve this equation for X, this gives us a new way to solve a system of equations. So the next step is going to be to find the inverse of matrix A and then multiply both sides of the equation by that inverse matrix. Now remember, if we multiply A inverse times A, that will give us the identity matrix. Next, if we multiply the identity matrix times matrix X, remember that will give us just matrix X. So by following this process, we have solved the matrix equation for X, so the variable matrix will be equal to the product of A inverse and B. Let's go ahead and take a closer look at this on the next screen. This is the same system we saw on the previous screen. So if the matrix equation was AX equals B, we would have the matrix 3, negative 1, 2, 1 times the variable matrix would be equal to the matrix 5, 5. So again, here's our matrix A, here's our variable matrix, and here's matrix B. What we want to do now is multiply both sides of the equation by A inverse. Since this video focuses on the process of using a matrix equation to solve a system, we're going to go ahead and find the inverse of matrix A on the graphing calculator. So we're going to press second matrix, go over to edit, press enter. This is a 2 by 2 matrix, so it's 2 by 2. I've already typed in the elements, you can see them there. So let's go ahead and go back to the home screen to find the inverse of this matrix. So we'll press second, quit, and now we're going to call up matrix A, second matrix, select matrix A, and then press the inverse key here, and then press enter. This is A inverse. Let's go ahead and convert this to fraction notation. So we press math, enter, enter. We're going to multiply both sides of the equation by this 2 by 2 matrix. So what we've done here is multiplied both sides of the equation by A inverse. So now we have A inverse times A times matrix X must equal, this is A inverse times matrix B. So we know that A inverse times A would be the identity matrix. So this will give us the identity matrix times the variable matrix must equal this product here. Let's go ahead and determine this product. This is a 2 by 2 and this is a 2 by 1, so we can multiply those two and the result will be a 2 by 1. So row 1 times column 1, 1/5 times 5, that'd be 1, plus 1/5 times 5, that would be 1 as well. 1 plus 1 would give us 2. Now we'll multiply row 2 by column 1, negative 2/5 times 5, that's negative 2, plus 3/5 times 5, that would be 3. So negative 2 plus 3 would be positive 1. Lastly, we know that the identity matrix times the variable matrix would just be the variable matrix. So we now have the solution to this system where X equals 2 and Y equals 1. So using matrices to solve a system of equations is a great option, especially if you have technology to help you find the inverse matrices. Let's go and take a look at another one. We can apply the same idea for a system of 3 equations in 3 variables. So let's go ahead and set this up. Let's call matrix A the coefficient matrix, so it'll be a 3 by 3 matrix. Then we'll have our variable matrix, and then we'll have our constant matrix. We'll call it matrix B. This is a 3 by 3, this will be a 3 by 1, and this will also be a 3 by 1. So the coefficient matrix will be 1, -3, 3, 2, 3, -1, and 4, -3, -1. The variable matrix will be x, y, z, and the constant matrix will be -4, 15, 19. So the matrix equation would be the coefficient matrix times the variable matrix must equal the constant matrix. So our goal is to solve this equation for the variable matrix. So what we're going to do is multiply both sides of the equation by the inverse of matrix A. Let's go ahead and find that on the graphing calculator. Second matrix, go over to Edit, press Enter. It's a 3 by 3 this time. And we'll go ahead and enter the elements. Now we'll go back to the home screen to find this inverse matrix. So we'll press second matrix, enter, then the inverse key, press enter. And let's go ahead and convert these to fractions. So math, enter, enter. And there is our inverse matrix. Notice there's some numbers over here on the right. We can press the right arrow to view all of them if needed. Let's go ahead and take this information back to the presentation. Now we are going to multiply both sides of the equation by the inverse of matrix A, but I'm going to shorten this a little bit. I'm going to go ahead and just write A inverse times, here's matrix A, times XYZ must equal the inverse matrix and we'll multiply this by the constant matrix. On the left side, we know that A inverse times A is going to equal the identity matrix, and the identity matrix times the variable matrix will just equal the variable matrix. So we'll have X, Y, Z must equal the product of these two matrices. And we're going to go ahead and find this product on the calculator. So what we have to do now is enter in the constant matrix into matrix B. So I'll press second matrix, go over to Edit, and then down to matrix B, press enter. It's a 3 by 1, and the constants are -4, 15, 19. Okay, let's go back to the home screen. Let's clear this. We're going to go ahead and find A inverse times B. So second matrix, select matrix A, and then select the inverse key, times matrix B. So second matrix, select B, and then press enter. And so we have the matrix 5, 1, -2. Let's go ahead and write that down. So the solution to this system would be x equals 5, y equals 1, and z equals -2. So it's a great way to solve a system, especially if you're allowed to use technology to find the inverse matrix as well as find the product of matrices. But either way, this is a great application of matrices. I hope you found this explanation helpful. Thank you and have a good day.